We're doing some word problems. This is where we get to apply the math that we have learned. This is the type of problem where we are given the rate of work, the rate that it takes to do work by individual people separately, and then we're asked if they were to do the same job together, how long would it take? So problem number 6, it says, an old conveyor belt takes 21 hours to move one day's coal output from the mine to a rail line. A new belt can do it in 15 hours. How long does it take when both are used at the same time? So we use the formula rate times time equals job. So we're going to do this for the old belt, for the new belt, and then together. And we set up a chart. So the rate for the old machine is 21 hours. The time, it takes 21 hours to do one job. So the rate is going to be 1 over 21. Imagine if you had r times 21 equals 1 and you're solving for r. So you have to divide both sides by 21. So the rate is 1 over 21. For the new machine, it takes 15 hours to do one job, so the rate is 1 over 15. When they work together, the rate will be added together. Think about this. If it takes the old machine 21 hours, the new machine 15 hours, when they work together, it has to be less than 15 hours, because if the new machine works just by itself, it can do it in 15. Now the old machine is going to help it, so it's going to take less than 15. So these two rates will be added together, the 1 over 21 and the 1 over 15. We're solving for t. In other words, we don't know how long it's going to take, but we want to still do the one job. Notice we're not doing two jobs. Okay, if they were going to do two and they work together, obviously it would be 36 hours that it's going to take them. But they're still doing the one job, meaning 1 day's worth of coal output. Okay, so rate times time equals job. So 1 over 21 plus 1 over 15, that's the rate together, times t equals 1. So we have to get a common denominator. So we have to get the prime factorization of this denominator. That's 3 times 7. This one is 3 times 15. So our LCD has to have all of these factors, which is 3 times 7 times 5. So that's our LCD, 3 times 7 times 5. So we have to multiply this one by 5 over 5. And we have to multiply this one by 7 over 7. So we get 5 here and 7 here. So this is 5 over 105. This is 7 over 105. Which adds up to 12 over 105 times t equals 1. So we're solving for t. T is multiplied by a fraction. To undo this multiplication of the fraction, we can either divide both sides by 12 over 105, or we can multiply both sides by the reciprocal of the fraction that we're trying to get rid of. That's a better way of doing this. Instead of dividing by a fraction, multiply by the reciprocal. You see, these cancel, so you just get 1t equals, and then 1 times anything is just that thing. So that's 105 over 12, which is 8.75. And the units is hours. Okay, so as you see, when they work together, it takes less than 15. That would make sense that it takes 8.75.